Alright, you math maniacs, this is section 3.41, solving rational and radical equations, day 1. What's a rational equation? I'll tell you, a rational equation is an equation with fractions, because really the word ratio means fractions, two numbers compared to each other over a fraction bar. So a rational equation has fractions in it, and look, all these examples have fractions in it. Here's the overall strategy. We have to find the least common denominator. So, for example, the least common denominator of 2 and 3 is 6. Yay! The least common denominator of all this craziness is going to be something crazy also. But that's okay, we can do it. Then we're going to be clearing the fractions. So, getting rid of this fraction bar so that we have something easier to work with. And you can see that step is kind of in blue. And then we're going to solve it and check our solutions. It's so important to check because, as we'll see in a moment, sometimes the solutions don't work out. For example, here we've got just a process that leads to x equals plus or minus 3, and you might be tempted to say, oh, well, we've got both answers, plus or minus 3, but when you check one of them, you get zeros in the denominator, which you're not allowed to have. And so the answer should not be positive 3. It could only be negative 3. We have to go from having two solutions down to eliminating one of them so that we have only one solution here, the one that works. So let me show you what that looks like specifically. Here we've got x over 2 plus x over 3 equals 10. And I figure out that my least common denominator is 6 because the least common multiple of 2 and 3 is 6. How did I get that? Well, 6 is 2 times 3, and so that's kind of the easiest way to think about it. In order to get this common denominator of 6, we have to multiply the entire fraction by something. The thing that's lacking is the 3, so it's 2 times 3 gives you the 6. So multiply the numerator and the denominator by 3, and you get 3x, and you get 3 times 2, which is 6. Here, the thing that's lacking in the denominator is the 2. So we multiply the entire fraction by 2, and then both the numerator and the denominator get 2x over 6. And now that we have common denominators, we can add the two fractions together to get 5x. Great. Clear the fraction to get, multiply both sides by the denominator, which is 6, and you get 5x is equal to 60. Dividing both sides by 5, you get x equals 12. Great, that's the answer. And you do need to check all your answers here in this section because sometimes some of them might not actually work out. They're called extraneous solutions. But we can see here 12 divided by 2 is 6 and 12 divided by 3 is 4, 6 plus 4 is 10. It all checks out. So x equals 12 is not an extraneous solution, it's the one real solution. Here. X squared over x minus 3 equals 9 over x minus 3. The least common denominator is going to be x minus 3. In fact, it already has common denominators. So we don't really have to change anything. Here, then we have to clear the fraction. So we're going to multiply all the terms on both sides by the denominator, x minus 3, to clear the fraction. So this used to have fractions, but now it has just x squared equals 9. When you take the square root of both sides, you have to examine both the positive and negative. X is equal to plus or minus 3. Great. When we check these answers, we find that if you try and put a 3 in for x, the numerator is fine, but the denominator has a 0, and that's not allowed. 9 over 0, we can't even figure out what that is. We can't divide 9 divided by 0 and get an answer, and you can't do it here either. So as soon as you have zeros in the denominator, then you have to eliminate this as a possibility. X should not equal 3. But over here on this side, you can have negative 3 squared, and that's fine. It gives you 9. And on the denominator, you have negative 3 minus 3, which is negative 6. This checks out. That's fine. And so the one solution is x equals negative 3. eliminating the extraneous solution of x equals positive 3, because that you can't just zeros in the denominator. Next, look at this craziness. Alright, so here we have these three fractions, and the real goal is to find the least common denominator between all three fractions. It's actually impossible to really think about when they're not factored, so the first step would be to factor these denominators. And so here, just to decode everything, I've got all these dots everywhere, and the dots represent the different factors that I find. Look, there's an x plus 2 here and an x plus 2 here. There's an x minus 2 here and an x minus 2 here. And there's a 3 all the way out here. Now what some students might do is they might, just like in the first example, they might just say, remember the first example was 2 and 3, and you multiply the 2 together, you get 6. Well, you would get a common denominator if you multiplied this times this times this, all three of these denominators together. You would get a common denominator. We wouldn't get the least common denominator. It's actually a lot, that would be a very incredibly complicated way to do things. It's a lot easier to think about the least common denominator as making sure you're covering all the factors, cover all your bases. You need to make sure you have one red and one blue and one green. And if you do, you'll be able to multiply all these fractions up to the least common denominator, the red, the blue, the green factor. So here, you have a red and a blue. What are you missing? You're missing the green in order to get up to the least common denominator. And that's why you need to multiply this entire fraction by the green factor. And then you have a red and a blue and a green. So you notice the denominator multiplied by green gives you the least common denominator. And then you also have to do the same thing to the numerator. 2 times the green factor is here. Here, we've got 2 of the 3 factors, the blue and the green, but we're missing the red, so that's why we multiply the entire fraction by the red factor. 1 times 3 is in the numerator now. And in the denominator, we have the least common denominator of 1 red, 1 blue, and 1 green. Here, we've got the green factor. We're missing both the red and the blue, which is why you need to multiply the red and the blue to get to the least common denominator. Red, blue, green, red, blue, green, red, blue, green. So this would be 4 times the red and the blue factor. Whew. Now that we've got all that, we can combine the fractions. Since the fractions have common denominators, we can add these two together. 2x minus 2 plus 1 times 3. They get right there. And it's keeping this side the same. Now, let's clear the fractions. Now that we have everything combined and added together in least common denominators, we can clear the fractions. And so that's basically multiplying both sides by the least common denominator, the red, blue, green. And once we do that, we just have the remaining numerator here. So you can see this remaining numerator is recopied down here. Two x minus 2 plus 1 times 3 equals 4 times 3 times x plus 2. So now the rest of it is simplifying. We distribute here, and then I subtract 2x from both sides, combining minus 4 and plus 3, you get negative 1. And then subtracting 24 from both sides, you get negative 25. Dividing both sides by 10, you get x equals negative 2.5. That's my one solution. Now, does it work in the original? I do have to check it algebraically. This is not just like math teachers saying, by the way, check your answers because you might have made a mistake. No, you actually, the algebra requires that you check your answer just to make sure it's not an extraneous solution. Because remember, when you have these in the denominator, when you have x's in the denominator, there could arise problems. So here, I check it in the original, and I don't get any zeros in the denominator. And if you type all this out on the calculator, you'll find that the left-hand side does in fact equal the right-hand side. So here you can see on Desmos, I typed in the whole equation, and I got this vertical line which intersects the x-axis at negative 2.5. So there it is. That's confirmation that x has got to equal negative 2.5 graphically. I'd like you to try this. Try example 2, and just remember that Little Rock is the capital of Arkansas. never been there, never even set foot in Arkansas, but Little Rock is the capital of Arkansas, and if you've been there, then you can let me know tomorrow in class. Go ahead and begin 3D1, copy the problem list, and do the first problem.